This recording is to help you with the lesson 10.02 on ellipses. Alright, so to start things off, I copied all the equations from the end of the formula. All of these equations that you see at the very end of the lessons, they're going to be your best friend throughout this entire unit. It basically summarizes everything you need to know in one spot. So at the end of every lesson in the beginning here, you're going to see kind of a chart that looks like that. Make sure that chart gets down in your notes. Okay, so make sure it gets down in your notes because you can use it for your homework. You're going to use it on your test. It's very important. Okay, so to find the center, vertices, foci, and eccentricity of an ellipse, we need to first write the equation in this form here. Okay, so to do that, we're going to separate the x's from the y's, and then we'll move the constant to the other side. So I'm just going to kind of rewrite it as 9x squared plus 36x. Then I'm going to leave some spots here and move on to my y. So 4y squared minus 24y. Leave some spots, and I have a plus 36, so I'm going to subtract 36 from both sides. I'm going to see if I can move this so I'm not writing over everything there. Okay, I'm going to complete the square, but before I can complete the square, I need to factor out a 9 from the x's and a 4 from the y's. Because we can't complete the square until we have a 1x squared there. Factor out a 4, that leaves me with y squared minus 6y. Alright, to complete the square, we take half of our middle term, so half of 4 is 2, square it is 4. But we're not adding 4 to this side, we're actually adding 36, because remember we take that 4 times 9. And then in my y's, half of negative 6 is negative 3. Negative 3 squared is still a positive 9. So again, 9 times 4 is a positive 36. So I get x plus 2 squared and y minus 3 squared equals 36. But we don't want it to equal 36, we want it to equal 1. So what we would have to do then is divide each part by 36. Okay. So that would give us our formula up here then. X plus 2 squared over 4 plus y minus 3 squared over 9 equals 1. Now we can start picking out the information we need to find the center, the vertices, the foci, and the eccentricity. Well, the center is just your opposites here, so negative 2, positive 3. So those are your centers. To find the foci, we notice that we are using this equation right here. 9 is bigger or larger, and it's under the y. So a squared is under your y. A in this case is the square root of 9, which is 3, and b is the square root of 4, which is 2. In order to find c, we would have to do b squared equals a squared minus b squared. And we know that this is 4 equals 9. Let's subtract 9 from both sides. C equals 5 once we get rid of the negative, so C equals the square root of 5. So we found the center, now we have to find the foci, so that's just plugging in our information here. So the h's are not changing, so it stays in negative 2, because that's what your h was for your center. And then we do k plus c and k minus c. So k was 3, so we'll do 3 plus or minus the square root of 5. And then for your vertices, again, your h's are staying, so stays negative 2. And then we have k plus or minus a. So 3 plus 3 is 6. 3 minus 3 is 0. And the eccentricity is just found by doing C over A. It's a ratio here. So we'd have the square root of 5 over 3. And my next one's not quite as bad because we have to find the equation of an ellipse with the center at the origin. So knowing that, I know h is 0 and k is 0. Okay. We know the foci is plus or minus 5, 0. So let's look down here. If the foci is changing because it's a positive 5 and a negative 5, that means we must be using this equation right here. Okay, so let's just figure out what C is going to be according to my foci. So if I have h plus C, and that equals, if I'm adding, it should equal the larger of the two. And the larger of positive or negative 5 is obviously a positive 5. I know h is 0, so that means C must equal 5. Okay. So I get C equals 5 from that. Now the major axis has a length of 12, so I know that 2A equals 12, therefore A equals 6. So that's how I was able to get A. We can now find B by using my formula here. So B squared, and in fact we actually will want B squared for our equation. So B squared equals A squared, which is 36, minus C squared of 25. So 36 minus 25 is 11. And I think we have everything we need now. So looking at my equation, let's plug our information in. X minus 0 squared over 36 plus y minus 0 squared over 11 equals 1. So that gives us our x squared over 36 plus y squared over 11 equals 1. For the next one, we have to find the center first. I think that's where we should start. So looking at my graph, my center is at the point right here, which appears to be 2, 2. Okay, so if the center is 2, 2, we can then find what A and B is. It looks like my major axis is parallel to the x-axis there. So we are using this formula or equation right here. A is half that length, so half that length appears to be 3. And B is your minor axis, or half your length of your minor axis. So half the length of that blue highlighted portion is our 2. So plugging this information in, we'll get x minus 2 squared over 3 squared, which is 9, plus y minus 2 squared over 2 squared, which is 4, equals 1. The last one I'll go over today, we know the center is at 0, 4, and I know A equals 2C with vertices of negative 4, 4, and 4, 4. Now in my vertices, I notice that the y values are the same. So to see what equation I'm going to use, I look for where the vertices are, where the y constant, or the y coordinates are the same, which is here, parallel to the x-axis. Okay. From here I can say, well, h plus a must be the larger of the two vertices. So that's a positive 4. So h plus a equals positive 4. Well, I know h is 0 from my center. So looking at this information, I can get a equals 4. I can also use substitution because I know a equals 2c. So if 2c equals 4, then c must equal 2. Or if you know what a is, then again you can just plug it into here and get 2 also for c by doing it that way. Okay. So either way, we have a equaling 4 and c equaling 2. We need to find out what b squared is. So using my equation here, I can insert what I know. I know that a is 4 and c is 2. So 16 minus 4 is 12. So b squared is 12. Now I don't need to figure out what b is because I want b squared in my equation. So when I go to write my equation, I'm going to use this formula here and plug in what I know. I know h is 0, so that's how I get x squared over a is 4, so that's 16, plus y minus 4, because k is 4, over 12 equals 1. So here is my equation for that one.